Okay, then let's start. Is my voice loud enough?
Yes, sir.
We started what circular array is. Okay, in the previous lecture, there's the question like a lot of students are facing problems with the term arrays, what array is, what it means, and so on. For now, let's say arrays and lists mean the same thing. Okay, whenever we hear the word array, let's say this is the same as list. For now. So in the next week or so, we're going to look into this in a bit more detail. But for now, let's say lists and arrays are the same things. They are data structures which store multiple data, and those values are accessed using index numbers. Okay, in the previous lecture, we started what the circular array is. Circular array, although the name has the word circular in it, the physical data structure is nothing like this. It's not a circle. In fact, it is a linear array, but we traverse it in such a way. Traverse means we run loops in such a way that it seems we are moving in a circle. There are a few more differences. For a linear array, the starting index is always 0, but for a circular array, the starting index could be anything between 0 and length minus 1. This is a linear array where I have four numbers 1, 2, 3, 4, starting from index number 1. Starting from index number 0. This is a circular array where I have the same numbers in the same sequence 1, 2, 3, 4, but instead the numbers start from index number 2. This is the starting index of the circular array. These are the differences. Now, while running a loop in a linear array, it's pretty easy. We start from 0 and we traverse until we reach the end. But for a circular array, we also start from the starting index, which could be anything between 0 and 3. Let's say for this particular example, the starting index is 2. Same concept, we start from the starting point n We circle and we stop at the ending point. We are basically doing the same thing over here. We're starting from the starting point and ending at the ending point. But the problem is, in linear array, we're moving in a linear fashion, straight line. Zero, the indices are 0, 1, 2, 3. But for a linear array, we are not moving in a straight line, we're moving in a circle. Let's say we have to print the elements of a circular array. For example, this is a circular array and I have 4 numbers and the starting index is given 2. The size is given. I have already discussed the difference between size of an array and the length. Size means the number of elements present in the array, and length means the capacity, the number of elements as an array can hold. As there are 4 elements present in this array, the size is 4. The starting index and size is given, and I have to print the number of, I have to print all the numbers. By looking at the diagram, I'll always go looking at the diagram. I'll always draw and code from the diagram. I'll never try to memorize, because memorizing code will never help. If you look at the diagram, I should start printing from index number 2 and then print and keep on printing, moving forward and printing. So I start, and I also have discussed that I'll always save the starting variable, the starting index in a temporary variable, so that I don't lose it in the middle of my program. So before I start my program, I take a variable and let's name it temp, and I save the starting variable inside the variable temp. So start and temp points to the same index at the beginning. Now I'll print the element inside temp, which is 1. This is the output. 1 gets printed, and then I'll move forward. That means I'll increment 10 by 1. I'll move to the next index. Increment 10. Do the same thing. Print the element inside the index pointed by 10, which is 2. Increment 10. Once temp reaches beyond the length, I bring temp to index number 0. That is, I'll have to put an if condition. If temp reaches beyond the last index, I make temp 0. Then I print 3. Then I print 4. And then I stop. Now, there is one thing missing in this piece of code, that is the loop. A lot of people do this mistake. By looking at the picture, it seems like I start printing from this is a mistake that most of the students make. It seems from the outside that we start from the starting index and we go up to size. Size means the number of elements. But this is wrong. Let's trace and find out. Initially, the value of temp is 2 and the size is 4 because there are 4 elements present. Uh, so this condition satisfies because the value of temp is less than size. So I print the first number, increment 10, 10 becomes 3. I check in the while condition, this satisfies again because 3 is less than 4. I print the second number and increment 10, 10 becomes 4. Once 10 becomes 4, 10 is no longer less than size, which means the condition of the loop is dissatisfied and my loop breaks. When my loop breaks, I get the first two in output and I do not get these two these two numbers, which is wrong. This is a mistake that most of the students make. What I'll have to do is I have to run this loop size number of times. If I run this loop one time, I get one number printed. If I run this loop twice, I get two numbers printed. If I run this loop 3 times, I'll get 3 numbers printed. Therefore, if I run this loop size number of times, I'll get all the numbers printed. So I'll have to use a separate variable to count to make sure that I reach size, and that will be my counter. Say I is equal to 0, I is less than size, and I do I plus. This I is my counter. This I counts how many times I've printed. Starts from 0. Every time I do a print, it's incremented by 1. Therefore, this loop will run size number of times. When I match a size, my loop breaks. Now, if I start from 0 and keep on incrementing until I reach size, I print 4 times. So this is the trick while working with circular arrays. When dealing with lists and linear arrays, the starting index is always 0. Therefore, we don't have to worry about this. But while dealing with circular arrays, the starting index is not 0, not always 0. It could be anything. It could be 0, but it could be other numbers as well. Therefore, we have to be careful. We have to work in this way. So any question to this point? Okay, if there are no questions, let's look at it as a different example. So you'll be given a circular array and you'll have to print the numbers or the values inside it in a reverse manner. So let's draw the scenario again. If this is my circular array and this is my start, printing the numbers in a reverse manner means the output should be 4, 3, 2, 1. This 0 is not printed because 0 means an empty space. So do not print the empty space. This is what I should, after write a program that gives me this output. Looking at the diagram and looking at the output, I can say that I have to start printing from this particular index, which contains the last element, and then I have to move backward, and I have to print till till the start. The previous example we dealt with printing the numbers forward. In this example, we're dealing with printing the numbers in a reverse manner. And from by looking at the output and the diagram, we see that we have to start from the index containing the last number and move backward until we reach the start. Now the question is how to find the index containing the last number or last element. How to find the index containing the last element? One answer is I can run a loop and find where the last number is, which might be a bit tedious. And the other way to find the last number is using a formula, very easy formula. Starting index plus size. For this particular array, the starting index is 3. The size is 4, which is equal to 7. Modulus length of this array, which is 5. The answer is 2 because modulus, this is the remainder. And then we subtract 1, which is 1. So my answer is correct. 1 contains the last element. So now I take a variable, let's call it x, and this is the last index, and I know the formula to find the last index. It's this, and using this formula I find the last index and I save it inside a variable named x, and then I print this element because this is what my output says. I print this element and then I move backward. So the first element gets printed, I move backward, I print again. The second element gets printed, I move backward, but here's a problem. Moving backward from 0 gives me a negative number, and we know arrays cannot have negative indices. Therefore, when the pointer reaches a negative number, we bring it to the last index of the array, which is length minus 1. In the previous example, when we were moving forward, when x reached beyond the length, we took a U-turn to index number 0. Here we're doing the same thing, but in a reverse direction. Similarly, I'll have to have I'll use an if condition. If x becomes negative, x will be length of array minus 1, which is the last index of the array. And this printing continues until x reaches 3. Now this printing must be done in a loop like the previous example. There has to be a loop over here. What should be inside the loop? What should be the condition inside the loop? It's the same condition as the previous example, because this loop tells me how many numbers we're printing. It does not deal with if you're printing in a reverse manner or a forward manner. We use this loop to count the numbers we're printing, which is size. Similarly, we use a variable. Let's name it I, and we say, well, I is less than size, and at the end I increment I. I hope you understand what I'm trying to say. This is the trickiest part dealing with circular arrays. And this condition, of course, this is something you've not seen this before. My suggestion would be always draw the scenario that I'm doing, and then write your code. Okay? Any questions? Okay, so let's look at a different example. Let us try to shift the numbers. In the very first lecture, I did explain what a left shift and a right shift means. And I've also explained rotations, right? Shifting in a linear array is moving the elements to the right or to the left, and we lose data, and the value at the very end or at the very beginning is lost. So we have data loss. While rotating a linear array, we do not have any data loss. Instead, the value at the beginning or the value at the end is rotated, comes back. So no data is lost. If you look very carefully, rotation in a linear array is basically a circular array. Rotating a linear array is basically a circular array. Therefore, and shifting and rotating in a circular array basically means the same thing. As we are considering the array to be circular, if we shift the numbers don't fall off because there are no edges. As linear array had edges, numbers do fall off when shifted. But when we work with a circular array, we assume that the array is a circle. Therefore, if we shift the numbers, it is the same as rotating the numbers or rotating the values. They rotate. Shifting and rotating, in both the cases, the numbers rotate. Hence, shifting and rotating in a circular array is the same thing. But for linear arrays, shifting and rotating are different. You have to keep this in mind. Therefore, if I say do a left shift in a circular array, it's same as doing a right, left shift in a circular array is the same as doing a right rotate, left rotate in a circular array. Now let's see how it's done. Zero means a blank space. Let's say I'll do a left shift. Left shift means all the elements will move one space to the left. I'll start from the very first number and I'll start by moving it to the left. Now this looks pretty easy because this is an empty space. I'll easily move this number to an empty space, which is quite trivial. But what if there were no empty spaces? What if there were no empty spaces? Moving this number to this index would replace this number 8. I don't want to lose any piece of information. So in this case, when the array is full, what I do is I save this number in a temporary variable. So let's say I have a variable temp and I save the last number inside the variable temp. You can name the variable anything you want. I'm calling it temp. I'm calling it temp. And we know the formula to find the last number. I'm not writing it. I explained it in the previous example. So we already know the formula to find the last number, and I save the last number, which is 8 in this example, and I'm saving it inside the variable temp. And then I'm making it a 0. Oh, sorry. It's instead of a last number, it's a last index. And then after I save 8 in the temporary variable in temp, I'm making it 0. I'm making it 0 because if I look at this now, it looks like I have an empty space. So it'll get a bit easier for me to code. This line is not necessary at all. I'm writing it for my own benefit. It looks good. It now looks that I have an empty space. Now what I'll have to do is I'll have to move this number to the previous index. Now I'll take two variables. One, let's call it x, which will point to the start. And I'll take a second variable, let's call it y, which will point to the last index. I mean where I'll shift the number 2. Okay. So what I do is I shift the number pointed by x to the index pointed by y. This means 0 gets replaced by 1. I increment x, then I increment y. And then I do the same thing. Shift the number pointed by x to the index or the box pointed by y. Therefore, 1 gets replaced by 2. Increment x. X goes beyond the last index. Therefore, I have to put an if condition. Once x goes beyond, I bring x to 0. I replace 2 with 3. I increment x and I also increment y. Now y goes beyond the length, therefore I also have to put a condition for y. Therefore y comes here. Do the shifting again. 3 gets replaced by 4. Increment y and increment x. Now I stop. Once x reaches this particular index, I stop because this is where the shifting is done. So this shifting is done inside a loop, similar to the previous examples. And the loop condition is exactly the same. After the loop ends, my resultant array looks like this. After the shifting, my resultant array looks like this. I have an extra 4 at index number 1, which is pointed by y. Now what I do is, remember I saved a value inside temp. I replace this 4 with temp at the end of the loop, right? So this is where my loop ends, and outside the loop, I replace this value with temp. This particular value is pointed by y, therefore I've used the index y and replace it with temp. Now there's one little problem. If you look carefully, the starting index was 3, which means the number started from index number 3. But when I do a shift, now the first number starts from index 2, which means I have to change the start index. At the very end, I decrement start. Questions so far? Okay, I take your silence as you don't have any questions. This shifting is required when we will add and delete elements in a circular array. All concepts are similar. If no matter if we are working with a linear array or a circular array, the concept is similar. We shift, we rotate, we add elements, we delete elements. But what differs is, or what differs are, the way we are running the loop and the starting positions. Other than these two things, the concept is exactly the same. In the next lecture, we'll see how to add and delete elements. And we'll discuss a bit more about list versus arrays. And please make sure you look at the lectures uploaded in Bucks, and anything you don't understand in the lectures in Bucks, please to ask me, okay? As these online lectures are not mandatory, I cannot like teach you everything over here because not all students are present. In the live sessions, I'll basically solve your problems, answer your questions, and show you the main stuff. Do you have any questions so far? Any question regarding the Bucks lectures or any other topic? Okay, if we do not have any more questions, I'll end the lecture here today.
So
Yeah.
the question I had is not about the BX lectures. Actually, it's about the lab assignments in the instructions. Are we supposed to use also the naming convention as given in the questions, or we can use any we want?
You mean the naming convention?
Yeah, in the labs.
I think the naming convention is mentioned in the in the instruction. If you're confused about anything regarding the lab, I suggest you consult Sifat Miss. I'm writing her name in the chat box, or Anaf Miss. These two teachers are basically the coordinators of of this course. So if you have questions regarding these matter about naming conventions or submissions or anything, I suggest you discuss or ask question to these two ladies. Okay,
Okay, sir. Thank you.
I've written their names in the chat box. You can see.
Yeah, I can see.
Yeah, you can ask questions in Slack or you can send them an email if you want.
Okay, thank you, sir.
Oh, you're welcome. No other questions? Then we'll see you next week. Thank you very much.
Thank you. Have a nice day.
Thank you, sir.
Thank you, sir. Assalamu alaikum.